Question 16. Consider a process with the transfer function, this one. Let's write it down in a bigger way. Let's call it GPS is going to be equal to e to the minus s divided by 5s plus 1 whole square. This, of course, is my steady state gain. And this is my delay time, theta equal to 1, and two identical first order systems with the time constant equal to 5. So this is basically a second order plus delay time system, and let's call this as an SOPDT. So according to this problem, uh, for the process reaction curve, or the PRC of this system, we have to fit an FOPDT model. What is an FOPDT model? Let's quickly write it down. FOPDT model, let's call T FOPDT model would be equal to K e to the power minus theta m s divided by tau m plus 1. So basically, this is the first order plus delay time, and that's called first order plus delay time FOPDT model. Okay, so we have to fit the process reaction curve of this one to this particular model. So basically, based on the characteristic equation and the response of the system based on unit step input, we have to find out the parameters theta m and tau. Basically, we have to find out the ratio. That's what we have to find out. So that's basically the problem here. Okay. So first question might be, why do we do that? Normally this is done for any second order SPDT model or a higher order systems, so that fitting an FOP using an FOPDT model, it's easier to find out the control and tuning parameters. That's why it's done. Okay. Now let's dive into solving this particular problem. Solution. How we do it? Okay. Before that, let's quickly go to Seaborg and discuss the theory a little bit. So let's say this is my SOPDT model, PRC, or process reaction curve. Okay, and the FOPDT model is this one, and we have written slightly different here. The FOPDT, we have written this one as K e to the power minus theta ms over tau ms plus 1. Okay. The process reaction. So what the steps? The process reaction K is found by, so K we already know. We already have the value of K, and which is equal to 2. Okay. So that's done. Now what we have to do, a tangent is drawn at the point of inflection. So if this is a PD model PRC, that's process reaction curve, we have to draw a tangent at the point of inflection. So this is the point of inflection. For finding out the maximum slope, we have to find inflection by finding out the maximum slope. And how do we do that? The slope would be di over dt, okay? And to find out the maximum slope, we have to find out dy over square the second derivative equal to 0. And from there, we find out the value of the coordinates. We find out the coordinates and the slope. We find out the coordinates and the slope. Coordinates and slope of the process reaction curve. Okay. Now, if we draw the tangent, then of course it will share the same value of the coordinates and the slope. So the slope and the coordinates of this tangent would be the same as that of the PRC. All right. So once we know that, then what we have to do, the intersection of the tangent line and the time axis. So we extend this tangent line here, and this is my time axis, which is y is equal to 0 line. We have to find out this one here, and that is the value of theta. That's what it says. Okay. Now what we have to do? Um, Now we have to, if the tangent is now extended to intersect the steady state response time, so this would be my steady state response time. So this value would be equal to k equal to 2 in our case. So we have to find out, extend this tangent line here and see where it intersects at this particular point. So we have to find out this particular point here, and that would be, of course, we have to remember, be careful about, there will be a time delay here. So this would be equal to theta m plus tau n. And since we already know theta m from here, from step 2, we'd be able to calculate the value of tau n. And then, of course, we can find out the ratio of theta m over tau n over theta n. So that would be the strategy for solving this problem. Okay, let's see one by one how we do that. Okay, okay. Let's see. It is given. So we're taking this one. Now already some information is given. If the transfer function is this 1 over tau s plus 1 whole square, then already the value of y is given is equal to 1 minus 1 plus t over tau e to the power minus t over tau. That's already given. So here, of course, in our case, tau is equal to 5. Here, now because tau is equal to 5. So, and of course here, in our case, theta is equal to 1. And the value of k, the state gain is equal to 2. So, we can write this equation for this particular system, our system here, we can write the yt would be equal to 2, that's the steady state gain, 1 minus 1 plus, this will be t minus 1, taking care of the delay time, divided by tau is equal to 5 e to the power minus of t over 5. No, t minus 1 over 5. They will take care of the delay time. Okay. So that is how it describes the process reaction curve. So that equation is yt of the FOPDT model. Okay. So that is this one. Now we have to find out the inflection point. How do you find out the inflection point? So let's call it the step 3. Now we're going to find out inflection point. For finding out the inflection point, of course, the slope is dy over dt. That's the slope, and maximum slope would be when d2y over the second derivative equal to 0. Okay, and the second derivative is already given for us, so we can write y over dt square is equal to 2 over tau square from here. Tau square 1 minus t over tau. Tau is equal to 5 e to the power minus t over tau. Okay, and that will be equal to 0. Of course, that will be equal to 0 when 1 minus t over tau is equal to 0, or t is equal to tau, that is equal to 5. All right. And what will be the value of, and let's see, what will be the value of the slope? So t is equal to 5. this would be my at t is equal to 5, basically. T is equal to 5. And here, of course, the delay time is equal to 1. So at t is equal to really 6, there will be the inflection point. Okay. Now, what is the value of the slope at this point? Slope, that point of slope value is of course dy over dt, and that's given over as t by tau squared here. That will be equal to, of course, we have to take care of the steady state gain, t over tau squared, e to the power minus t over tau. We know the value of tau is equal to 5 and also t is equal to 5. Okay, and therefore this would be equal to times 5 divided by 5 square e to the power minus 5 over 5. So basically this becomes 2 bar over 5 e, and that becomes equal to 0.1471, right? So what happened here? T is equal to 6, this inflection happened. So this is the point of inflection. And here the value of slope is equal to 0.1471. And what is the value of y? Functional value of y. We can substitute that in this equation here. So what we can get is just one moment. Um, so basically, calculate this value here, the function value yt, and that of course is going to be equal to 2 into 1 minus 1 plus 6 minus 1 divided by 5 e to the power negative of 6 minus 1 divided by 5. And this becomes equal to 0.5284. So this value is 0.5284 at the point of inflection. So we got the value of yt at the point of inflection. We got the value of the slope also at the point of inflection, and we have got this value at t is equal to 6. Okay. Next point is we have to find out the equation of the tangent. Okay. We have to find that this is my tangent. Again, this is a straight line. It's really easy to do. So what we have here, we can write y of the tangent would be equal to m times t minus 1 plus c, and this slope here of the tangent of this straight line should be the same slope as the PRC, process reaction curve. So this m value is 0.1471, which is right here. Okay. The challenge is to find out the value of C. That can be done. We know that at the point of inflection, the value of y from the process reaction curve, which should be the same value as that of the tangent here, the same straight line. Whatever the value here of the process reaction, same value should be for the tangent. So we know this value is 0.5284. Okay, and we know this is 0.1471, and we know this is 6 minus 1. Okay, and plus c, we calculate the value of c, and it comes to be equal to negative of 0.2076. Okay. So what is the equation to tangent then? Y of tangent would be equal to 0.1471 t minus 1 minus of 0.2076. Okay, now let's go to the next part. So, part 7. Now we have to find out the value where this tangent line intersects this y is equal to 0. That's t line. Okay. And that will be my, wherever intersect, that will be my theta m, value of theta m. So this is very easy. You put y tangent is equal to 0 is equal to 0.1471. So this will be my theta m minus 1 minus of 0.2076, from where we get the value of theta m is equal to 2.4103. So if we kind of look into my FOPDT model, if you remember that, that is k e to the power minus of theta m s divided by tau m plus 1. Our objective is to find out theta m tau m. We already found out theta m. Next, we have to find out the value of tau m. Okay, what is the procedure? Which is now we have the equation of this tangent. Now we extend it and see where it intersects the steady state value, which of course for unit step transform is k equal to 2. So we have to find out the value of 2. So let's see what happens here. So we can write 8 here. Now we have to find out the value of tau m. Okay. And as I say, whatever this one would be, so this would be equal to, entire thing would be theta m plus tau m. Okay? So we have to now find out the value of tau m. So we say 2 because it is intersecting this line of y equal to 2 here, and this is my tangent. So intersection of 2 and the tangent line, y is equal to 2 and tangent line. So we put y is equal to 2 equal to 0.1471 into, this should be now theta n plus tau m minus of 1, okay, minus of 0.2076, okay. And from here we can calculate the value of tau n plus theta n is equal to, comes to be equal to 16, and therefore tau m comes to be equal to 13.5897, and this is my theta. So last part is very easy. So what we have to do, you have to find out the value of ratio of tau n over theta n, and that's going to be equal to 13.5897 over 2.4103, and that comes to be equal to 5.64638, and that is my answer. All the detailed calculation, references, and procedures are described in website solution.